simultaneous equations or solving equations simultaneously. Now, solving simultaneous equations, there's two basic methods that we use in school. The one is elimination, the method of elimination, and the other one is the method of substitution. Now, I prefer the method of substitution, although it is a little bit more difficult usually than the method of elimination. Let me tell you why. I'm just going to write this here. Maybe you've done both methods, maybe you've only done one. Substitution. Alright. These are the two methods. In general, for easier questions, the method of elimination is usually easier. The method of substitution is not impossible, but it's a bit more challenging than the method of elimination. But now here's the thing about the method of elimination. You can use this for two equations that are both in linear form. Sometimes when you have an equation in linear form and in quadratic form, it might be possible to use the method of elimination depending on how the equations are written and can you write them in the correct form to use the form of elimination. But then when you get to challenging questions like you have a quadratic and a cubic function that you have to solve simultaneously, you cannot use the method of elimination anymore. Right, and sometimes a lot of the times in university when you do have to solve two or even three equations simultaneously, you can't use the method of elimination. The method of substitution, for any problem that I throw your way, you are able to solve equations simultaneously with the method of substitution. Alright, so I prefer a method that you have to learn once and then you can use it up until your third, fourth year of varsity, and it's still a valid method and you can still solve any problem if you understand this method. I prefer a method that I can use continuously throughout, that I don't need to use another method for every other problem that I approach. So that's why I prefer the method of substitution. And I'm also only going to go through the method of substitution here. The method of substitution that I do might differ a little bit from what you've seen in school, depending on what your teacher told you. Usually the method of substitution has two sentences, mathematical sentences, like y is equal to 5x plus 6 and 2y is equal to 3x minus 4, things like that. And then the teachers teach you to go and number the equations and then substitute, get y from this one, substitute that into 1, substitute into 2, things like that. So if that looks familiar, this is the method of substitution. I'm doing the same thing, but I don't number the equations and I don't write every time substitute, substitute, substitute. I just have it in a little bit of another form, which I find is a bit easier to understand, especially for children still struggling with this procedure. Say for instance I have these two equations that I have to solve simultaneously. Y is equal to x minus 1 and y plus 7 is equal to x squared plus 2x. So then what I'm going to do is I'm going to, in one equation, find y or x alone. Now in this equation y is already alone, so I'm going to use that. But in this equation I'm going to work to find y or x alone until now I found y alone, but it's still in terms of x, so until I can't do anything anymore here, then I move to this equation. And then I substitute that, what I find here, I substitute in here. Then I'm going to simplify here as far as I can, and if I can't anymore, I go back to that equation. I take this, and take this information back to that equation, and then work with that. So if I know now that y is also x minus 1, I want you to think of this like, say for instance, there's a child, Peter Smith in your class, and some of the teachers call the children on their surnames, and the one teacher knows this child Smith, but he didn't know what his first name was. So then he will talk to Smith every day, and he knows Smith very well. But one day in the staff room, one of the teachers says, Peter has got an A in his Afrikaans, and I'm really proud because he really studied really hard. And then this teacher that calls this guy Smith is like, but who's this Peter? I don't know of a Peter in our school. And the other teacher says, Peter Smith. And the teacher is like, oh, okay, Smith. I know Smith. I just didn't know his name was Peter. Then this teacher learned some information that Peter and Smith is the same guy. Y and x minus 1 is the same thing. So Peter and Smith is the same thing. So whenever the other teacher now talks about Peter today did this and this and this in the mathematical sentence, the teacher who uses surnames can say Smith did this and this and this. In his head, he just replaces the Peter. Every time somebody says Peter, he now knows Peter is Smith, and then he just replaces Peter in his head with Smith because he knows the child is Smith. So this is how this works. It's the same thing, just in different forms. So if I know that y is x minus 1, I can go and make y. I just first write the whole sentence so that I get the information. And then I quickly replace y with x minus 1. And if there's more than one y, you will put brackets for all of the y's. And then replace. So now I have x minus 1 plus 7 quadratic equation. So I take everything to this side. X squared minus 2x is equal to 0. Then I just gather all of the x squareds, all of the x's. There's a x minus 2x, so minus x. Minus 1 plus 7 is 6. There's no more numbers. Plus 6 is equal to 0. And I don't like negative quadratic equations because this just complicates things for me. So I'm going to change this positive. Now you can always change the sign in a mathematical sentence, but if you change one sign, you must change all. So I change this one, then I change that one also, and that one also. And for 0, signs are not really relative, so 0 stays like that. And then I can factorize this. Hopefully you know very well how to factorize by this point. And then I find that x is minus 3 or x is 2. Right, now I actually have two brothers that are both Smith, and the one is Peter and the one is John. So now I have Smith is Peter or Smith is John, and I must, whenever I hear Smith, people talking about Smith, I must just find out whether this is Peter or John. So now I'm going to use this sentence, but in the place of x I must be able to substitute Peter, or it could be John, and I must further investigate. If it was Peter, which is minus 3, how would this work? Then minus 3 minus 1, then y would be minus 4. If x is John, so x is 2, then 2 minus 1, y is 1. So I have two scenarios. For the one x where x is minus 3, y would be minus 4. And if y is 2, what would happen? Y would be 1. So then if you get two answers, you substitute both these answers into that equation, and just make sure to put an arrow there. When you move from this equation to that one, put an arrow, then you work here. When you move from this equation back to that one, put an arrow. This just helps the people who marks your work to see what you did here. Because if you have here y is equal to x minus 1, and underneath that you break y is equal to x minus 1 into two mathematical sentences, and you just make the one x minus 3 and the other x2, where did you get that from? Can you see that this does not make sense if you work mathematical steps from there to there to there, but where did you get that from? You actually worked it out here. So you must just show here I substituted this in there, so that y is x minus 1 there, can you see? And then I worked this out, and then these two answers, can you see I substituted? So I broke up this equation into two because I've got two answers, and then can you see I substituted these answers, but there is where I got them. So then it just makes it easier for the person who marks your work to also see what's happening. And it's quite important not to just leave y minus 4 and y1. Please go and write, although you substituted x there and x there, please go and write your answer. This x goes with this y, and this x goes with this y, so that the person who marks your work can actually see, oh, okay, this person knows what he was working out. And especially if we do such long calculations, a problem many of us have in mathematics is that we get sidetracked, and we end up working out a lot of stuff, getting to an answer and think, phew, thank goodness I'm done, and then you leave it like that, and you didn't actually answer what they asked or answer the question. You just did a lot of calculations, and the first time you got to an answer you left it. So just to show clearly that I know the global procedure that I'm doing is now done because this is what they asked, and that is then my final answer. So just set that out neatly and properly so that the person marking your work can also see now you had something specific in mind. Right, so let's look at 3x minus y is equal to 2. Now you'll see this will now be a bit more difficult, because my y is not alone already, and 3y plus 9x squared is equal to 4. Right, now if you look at this equation, can you see that you can either get x or y alone, but can you see that it will be easier to get y alone because I can actually just take over the 3x and change the signs, where to get 3 alone, x alone, I have to get x alone, so take the y over and then divide by 3, but these are not divisible by 3, so I'm going to end up with fractions. Let me just quickly show you. If I have that and I divide by 3 throughout, then I have 2 over 3 plus y over 3, or a third y, which is fine, and you can work with that and substitute x there with, but can you see this is now an x squared, and if I substitute a lot of fractions, then I have this bracket 2 over 3 plus y over 3 squared in an equation that I must go and multiply out. So if I create fractions now here in the first step, it's not impossible to do it, but I'm creating a lot of work for myself. It's actually quite a nice challenge if you want to go and get x alone and do the procedure. With fractions, it might be a good challenge, but first just get a hold of how the procedure works before you try and attempt that. So I'm going to take over the 3x, and can you see that now I'm just going to change the sign, so this 3x becomes positive and the 2 becomes negative. I just swap them around because I don't like a negative in the beginning of the sentence. But either way, it's not a problem. Can you see that this would be now much easier to go and substitute there, and I can also substitute into just y and not the y that I still have to square. So can you see that this will be significantly easier if I get y alone. Then you must please show when you move to the other equation by using an arrow. So I have 3y plus 9x squared is equal to 4. I will do quite a few examples so that you can see the procedure over and over again and see how I adapt it for different things. But the procedure stays the same. First get x or y alone on this side, then you substitute it on this side. I continue with Peter is Smith on that side, so Peter I make Smith on that side, and then I simplify here until I get an answer or two answers for that matter, and that I substitute back into this x value. So I'm going to make y 3x minus 2, and then I'm just going to simplify this a little bit. 3 times 3 is 9x, 3 times 2 is minus 6, plus 9x squared, and then I'm going to take over the 4 because I see this is a quadratic equation, and quadratic equations works best. I solve by getting everything to one side, 0 to the other side. So I have 9x squared plus 9x minus 10 is equal to 0. So now I have this. Now I can probably do advanced trinomials here, but it might or it might not work. Let me quickly check for you. 10, 1, 5, 2. I'm looking for 9. That's not gonna work. That's not gonna work. That's not gonna work. I'm just quickly checking if it would be possible to actually, it is actually possible to do advanced trinomials. So let's do advanced trinomials because I'm always doing the formula. So just to show you an example of advanced trinomials. But you can also use the minus b plus or minus the root of b squared minus 4ac. Right, so I am going to find the factors of 9 and 10. Let me just put them here somewhere. I'm going to take them down now again from here. The factors of 9 and the factors of 10. And now I'm looking for factors from this column and that column that I multiply. Factor pairs that I subtract to give me 9. So if I have, for instance, 9 times 10 is 90. 1 times 1 is 1, so 90 minus 1, or 10 times 1 and 9 times 1, 10 minus 9. I'm looking for something like that that gives me 9. Can you see that 15 minus 6 will give me 9? So then this is my x factor, so I will have a 3x and a 3x instead of the usual x and x there. And then it doesn't really matter which one I put with which, because both of these threes are both of the x terms are threes. So 3 goes with 5 and 3 goes with 2, so it doesn't really matter. But usually we'll put them together inside, so 3 goes with 5 and 3 goes with 2. They go together inside and outside because it makes that middle term. And then my signs are different. The bigger one must be positive. Now I look at the 15 and the 9, and the 15 is bigger, so that must be positive, and the 6 must be, it's not 9, it's 6, sorry. 15 and 6, the 15 is positive and the 6 is negative. Right, so I can take this down. This you can do in pencil or in pen just here at the side of your book next to the problem if you have space, or do it a bit lower here at the bottom or something. I just did it here now so that it's still in the camera's view and you can still see what I'm doing. So I'm going to take it down now because I can't actually work here because I need to still work here. And then from this 3x plus 5 must be 0, or 3x minus 2 must be 0. So I get two values. This is minus 5. So x is minus 5 over 3, or x is 2 over 3. Right, so now I have fractions anyways, but now it's not that difficult to substitute a fraction into this equation and work with it, can you see? So I have two values for x, so I'm going to do this equation twice for 3x minus 2. The one for where x is minus 5 over 3, and the other one for where x is 2 over 3. So I just substitute these two values in there, and then from there on I can simplify. So y is, this is negative 5, because the 3's will cancel out. Negative 5 minus 2 is minus 7. If you're unsure, use your calculator. Especially in exams, it just erases the possibility of making calculation mistakes and losing the mark. So for something like this, which is a simple calculation, but I'm concentrating on a lot of things right now, use your calculator. Especially if the question doesn't specify you can't use one, use your calculator, and this will then be 0. So for where, and then now I have my answer for this x and that y, this x and that y. But now, just to make sure I've answered the question will probably say solve for x and y simultaneously. So you need an x-y pair which will satisfy both these equations. So I've got two xy pairs. The one is for x minus 5 and 3, minus 5 over 3. Y will be C for this x, this y will be valid. Or I've got another pair that will satisfy these equations. 2/3 and 0 will also work. And it might be worth just the exercise and the training that you get to go and check these answers. See if I substitute this pair into both equations, does it hold up? And if I substitute this into both equations, does it hold up? Just go see if it works, but that is my answer then. Okay. Alright, let's do one last example. One equation, x plus y is equal to 3. I think in the previous example I now again forgot to put the arrow up there. Please don't forget to put the arrow up there. If you see that there's something that you constantly make a mistake with, try and figure out a way to get the habit out of yourself to make that mistake. For instance, I see now that as I do these, when I think back to what I've done, I think I'm not sure if I did the arrow. I did this arrow, but I'm not sure if I did this arrow. And it's important that you show in your work where you went. So when I start with the problem, I know my mistake that I make here is I forget to put the arrow. So in pencil, I just put these arrows so that they're not going to be exactly at the right place, but so that when I have to put the arrows, I'm going to I can take out the pencil and just move them to where they should be. But if they're there already, I can see them, and I make sure that I don't forget to place them where they are. Right, so for this one I want to get x or y alone. Let's get x alone, just because in the previous two examples I got y alone. So I get x alone. Then I'm going to say in this equation 2x squared plus 2y squared is equal to 5xy, or you can say 5yx. It doesn't really matter. It's just easier if you have one expression that you multiply with the brackets. So I'm just going to say 5y and then x in the brackets. So my bracket is 3 minus y, and then I'm going to fill this in there and there. Notice that when I have more than one x value or more than one y value, this value I will substitute into every one of those x values of every one, or in every one of those y values. And now I just want to simplify this a little bit. So I'm just first going to multiply out this bracket. So I have 9 minus 6y plus y squared. If you don't know where this comes from, write these two brackets out like that and go and multiply them out and see if you agree with me, but you should. Plus 2y squared is equal to 15y minus 5y squared. So I have this. Now I'm just going to simplify this a bit more. So I multiply in the 2, 18 minus 12y plus 2y squared plus 2y squared, and I'm going to bring this over because I can see quadratic. Minus 15y plus 5y squared is equal to 0. Okay, there's just a 0 out of the screen. Right. Okay, so I have here, if I look at all of the y's, 2y squared plus 2y squared is 4y squared plus 5y squared is 9y squared. And then for this y terms, I have minus 12 minus 15, so this is minus 27y, and then plus 18. And then, well, can you see that all of these numbers can be divided by 9? Now if I have an expression, I would go and take out 9 as a common factor as to not change the expression. But because I have an equation, I can do the same thing this side and that side. I'd rather divide by the 9 and totally get rid of it, because I can divide 0 by 9 also and still have 0. So I'm dividing by 9, and in the process simplifying the equation immensely. Can you see? So now I can factorize this into y minus 2 y plus 1, no, y minus 1. So this is y squared minus 2y minus y is that, and that, yes. Okay, so then I have y equals to 2 or y equals to 1, and I can substitute that in there. So x, I have two values for y, so x I'm going to also have two values for, so I'm going to work out both. And oh perfect, my arrows are in the correct place and I haven't forgotten to write them, so that's quite nice. Good guess. I can maybe move this just a little bit, but it's fine. Okay, and then x is 3 minus 2 or x is 3 minus 1. So I substitute 2 and 1 in the place of y, and then I can work out x is 3 minus 2 is 1 and 3 minus 1 is 2. So I can have two values here. For x1, y must be 2. And for x2, y must be 1. And I can let's quickly check this answer. If x is 1 and y is 2, then 1 plus 2 gives me 3. And if x is 2 and y is 1. 2 plus 1 also gives me 3. So for this equation, these answers are both valid. Let's check this one. I'm just going to write it here. Plus 2y squared is equal to 5xy. So if x is 1, this becomes 2. And if y is 2, this becomes 2 squared for 8. So 2 plus 8 is 10. This side is 10 and this side is 5 times 1 times 2, which is 10. 10 is equal to 10. Perfect. And if I substitute these ones in, this pair in, I have 2 times 2 squared, which is 8, plus this becomes 2. 8 plus 2 is 10. And 5 times 2 times 1 is also 10, so 10 is equal to 10. Perfect. Alright, so just to check, and then I know, oh, these two pairs that I have here are perfect answers. They both work, and I know there aren't any mistakes.